Hello guys, welcome back for another question from inverse trigonometric functions. This is a proving question and let's see what do we have here. A question says something like cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. So a simple approach will be we can convert cos inverse term, this term, into sin inverse term, and then we can directly apply our formula of sin inverse x plus sin inverse y. But I don't think that we have such formula in NCERT. So we will go by our longer approach, that is we convert all the three terms into tan inverse. We convert cos inverse 12 by 13 into tan inverse, we convert sin inverse 3 by 5 into tan inverse, and we also convert sin inverse 56 by 65 into tan inverse. So moving one by one to all the terms, let's take 12 by cos inverse 12 by 13 as a first term. So I'll show you how to convert cos inverse 12 by 13 into tan inverse by the triangle method. They must have used the same way. I think it's not that explanatory. So let me show it for you. We have cos inverse of 12 by 13. That means this is 12, this is 13. Remember, this is a right angle triangle. Okay. This is 13, and by Pythagoras theorem this is root of 13 square minus 12 square, that makes it root of 25 is equal to 5. So we directly get our cos inverse 12 by 13 is equal to tan inverse 5 by 12. Let's see how they have done it. What they did, they wrote cos x is equal to 12 by 13. Then they applied the formula of sin square x plus cos square x is equal to 1, and they find out the value of sin x is equal to 5 by 13. Then they applied tan x is equal to sin x upon cos x. Sin x was 5 by 13. Sin x was 5 by 13. And cos x was 12 by 13. This thing is equal to tan x. So 13 and 13 cancel each other, and we get tan x is equal to 5 by 12. That implies that x is equal to tan inverse 5 by 12. So we get cos inverse 12 by 13 is equal to tan inverse 5 by 12. So we have converted our first term into tan inverse. Now let's hop on to the second term. Our second term is cos inverse 12 by 13. We already solved this part. We already solved our cos inverse 12 by 13. Yes. Our second term is this thing, sin inverse of 3 by 5. Okay. So again, we draw a triangle. This is a right angle triangle. And since this is sin inverse 3 by 5, so this is 3, this is 5, and by Pythagoras, this is 4. So we can write sin y is equal to 3 by 5, implies that tan y is equal to 3 by 4. Tan y is equal to 3 by t by. Tan y is equal to 3 by 4, which implies that y is equal to tan inverse 3 by 4. So sin inverse of 3 by 5 is equal to 3 by 4. Tan inverse 3 by 4. Now let us move to the third term and the last term on the right hand side, that is sin inverse 56 by 65. Okay, so let's draw the triangle again. This is a right angle triangle, and this is sin inverse 56 by 65. So this gets 56, this side is 65, and by Pythagoras this becomes 33. So we can write sin inverse 56 by 65 directly as tan inverse of 56 divided by 33. That's written over here. So now we have transformed all our three terms into tan inverse. Now moving to the next slide. What is our next step? What do we do? We take the left hand side. We replace all both the cos and sine inverse, cos inverse and sine inverse terms by their corresponding tan inverse terms, and then apply the formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus x minus y. Sorry, 1 minus x into y. So we have our x as 5 by 12 and our y as 3 by 4. Solving further and simplifying the terms, we get our final answer as on the the left hand side as tan inverse of 56 by 33. And we actually in the previous slide proved that RHS is also equal to tan inverse of 56 by 33. So we just proved that LHS is equal to RHS, and hence our problem is solved. I hope you all got it. Thank you.